Hello everyone, and welcome to Flow Core. In this demo, we're going to show you how to use Flow Core to save and load assets in a scene. For this example, we'll use a material. We'll walk through a simple case where we change the cube's material at runtime, then save that change and load it back successfully. Saving and loading assets is one of the key features of Flow Core, and this example gives you a clear look at how it works in practice. With that said, let's jump right in. Here, we'll first set up a simple scene. One cube, 3 materials in different colors, blue, red, and yellow, and 3 buttons: change, save, and load. Select the cube and add the Flow Core process component, which is the main runtime component in Flow Core. Then add a blackboard, which is used to store data. Next, add a bucket and set its type to material. Create 3 entries named blue, red, and yellow, and assign the 3 material assets we created earlier. You'll notice that the address field is empty at first. That's because Flow Core uses addressables under the hood when referencing assets. So all we need to do is enable addressable for these 3 material assets. Once that's done, the addressable field in the blackboard will automatically detect and display the addressable settings for those material assets. Create 4 Flow Core graphs named change, cube, save, and load. Then add a Flow Core process component to each of the 3 buttons as well, and assign the corresponding graph to each Flow Core process. Open the cube graph. Create a trigger node, then set its bus to global, which makes it a global event trigger. Set the channel to change color. You can also add the channel field to the whitelist, so it can be selected more easily later and helps avoid typos. Create a spinner node and connect the output of the trigger node to the in port of the spinner node. Rename the spinner's outputs to blue and red, then add one more output and name it yellow. Drag a connection from the spinner's blue port, then choose an action node from the creation menu. The action node is a special node used to execute specific instructions, and it's one of the most commonly used nodes in Flow Core Graph. Connect the blue port to the in port of the action node, then rename the action node to blue so it's easier to identify. Add an instruction and search for Set Shared Material. You'll see a group of related instructions appear. In Flow Core Graph, instructions usually come in 2 versions. One that calls the API directly through a component, and another that works through a GameObject. Here, we'll choose the Renderer GameObject version, which lets us call the Renderer API through the GameObject to set the shared material directly. Here, instance represents the reference to the current instance, and in this case, we can just leave it as the default value. Payload contains the runtime data passed along with the graph execution. It includes all the context information, making it easy for nodes to access shared runtime data. Self refers to the owner GameObject of this Flow Core process. In this example, when the graph runs, it refers to the cube GameObject. Scope defines where Flow Core looks for the renderer component relative to the current object, such as self, parent, or children. In this example, the renderer component and the Flow Core process component are on the same object, so we can simply keep the default value, self. Value determines which material will be assigned to shared material. Here, for the source, we choose the first local blackboard on the Flow Core process, so the index is 0 and the key is blue. You can also pick blue directly from the whitelist, which helps avoid typos. You can also add as many instructions as you want within the same action node, and they will be executed in sequence. Even better, Flow Core also supports asynchronous instructions, which we'll run into later. For now, though, let's stay focused on synchronous instructions first. Add a debug log instruction and print some message to the console. This is one of the most common debugging methods we use to confirm that the action has been executed correctly. Now, by duplicating the blue setup, we can very easily create the red and yellow actions as well. Of course, don't forget to change the corresponding key for each one. This time, we'll use Focus Mode to edit the node instructions. Once you're done, you can return to the main graph view through the navigation bar in the upper left corner. Now, let's make sure the cube is correctly linked to the local Blackboard. We can either add the Blackboard reference directly in the local block, or go into the Blackboard panel and click Add to Local. This will automatically add that Blackboard to the local list of the Flow core process on the same object. You can add as many Blackboards as you want, and inside instructions, you can reference different Blackboards by using different indexes. This gives you a lot more flexibility when setting things up, and it's also one of the key features of Flow core. Now, open the Change graph. Create a UI button click trigger. This node is specifically designed to respond to the on-click event of a UI button. Create an action node and connect it. Rename it to Send Signal. Then add a Send Global Signal instruction. Set the source to literal and the channel to change color. Since the Flow core process is already handling the button's on-click event, we don't need to set up anything extra in the button's on-click settings. Now we're ready to test it out. Let's enter play mode. Click the Change button, and you'll see a message appear in the console. It also shows the exact location of the debug log instruction, which makes debugging and troubleshooting much easier. Open the cube graph, then select the preview object as cube so you can monitor the graph's runtime state in real time. Visual debugging is also one of the key features of Flow core. Also, in the Flow core process panel, the runtime section shows the real-time performance of that Flow core process as well. We can also open the profiler to get a more detailed view of the runtime performance. With these profiling tools, we can quickly spot performance bottlenecks in Flow core and improve them right away. A solid set of performance analysis tools is a big part of what helps keep Flow core running fast and efficiently. Alright, now let's move on and finish building the save and load functionality. Open the cube graph and add two triggers, on save and on load. Add an action node and connect it to the on-save trigger. Rename the first action node to Get Material. Then create another action node, connect it to onLoad, and rename it to Apply Material. Inside the Get Material node, add a Get Shared Material instruction and choose the Renderer GameObject version. The setup here is almost the same as Set Shared Material. The difference is that this time, we're writing data back into the Blackboard. For the key, enter Current Material. As we can see, this key doesn't exist in the Blackboard yet, but that's completely fine. Flow core will automatically initialize the key with the correct type and assign the value for us. Being able to rebuild and extend the Blackboard at runtime is also one of the standout features of Flow core. We can also add a debug log instruction here for debugging. In Apply Material, all we need to do is apply the loaded current material back to the cube. We can do that using the Set Shared Material instruction. This time, let's use Flow core's instruction copy feature to quickly duplicate and paste the debug log instruction. Here's the corrected version of the graph. Open the Save graph, add a UI button, click Trigger, and connect it to an action node. Then add a save instruction to that action node. We can choose which save slot to use, and here we'll just use the default slot 0. Open the Load graph, add a UI button, click Trigger, and connect it to an action node. Then add a load instruction to that action node. We can choose which save slot to load from, and here we'll just use the default slot 0. Don't forget to add the current scene to the build settings list. Flow core's Blackboard data is scene-linked, which also allows Flow core to support cross-scene data persistence. Also, we can configure Flow core's save/load settings in the project settings, such as the save location, data encryption, and other related options. We can even define which scene should be loaded by default after the data is restored. For this example, we'll just keep the default setting, which means FlowCore will load the last saved scene after the data is loaded. Let's test our save/load system in play mode. Click Change, and the cube changes to red. Click Save. You'll see that the blackboard automatically creates a new key called Current Material and assigns it the red material asset. Open Show Cache, and you'll also be able to see exactly which data is currently being prepared for persistence. This is a very useful debugging tool. Now, let's enter play mode again and click Load. This will load the saved data we created earlier, and the red material should be applied automatically. That's everything for this video. Thanks for watching. I hope you enjoy the fresh new visual scripting experience that FlowCore brings to your development workflow. See you in the next video.